Good afternoon, all. On behalf of Honorable Sri Babanrao Pasputi Vidyadhara Trust, College of Pharmacy, Kashmir, I welcome you for this webinar on novel, eco-friendly, and economic applications of mixed solvents in pharmacy. Today, we have Dr. Maheswari. Sir is working as Professor Department of Pharmacy, Sri GS Institute of Technology Science, Indore. Sir has 33 years teaching experience, 2 years industrial experience. He is working as a member of Board of Studies at RGPV University, Bhopal. He has research
चालू
expertise
नहीं
in
हुआ।
mixed solvent concept in and in and he completed around 100 UG and PG projects and guided to PhD students. He has 189 research publications on his credit. He done 155 presentations in various conferences and published 6 books. He delivered 211 expert lectures. So today we have really very dynamic speaker. So I welcome you, sir, and I request you to kindly proceed. Thank you, sir. Yeah, sir, kindly proceed, sir.
हाँ, मैं शुरू करूँ ना?
Yes, sir. Yes,
मैं
sir.
हाँ, okay. Good afternoon to all of you. Firstly, I would like to thank Vishal Rasweji and Nirmalji, and of course the principal and organizers of Parikrama College of Pharmacy, who have given me a chance to discuss new research ideas in the field of solubilization for all of you. As soon as some doubt comes to your mind, please note it down. At the end, there will be session for question answer. So please note it down. Note down your questions. Okay. Now, since in this means an audience, there are so many students, B Pharm also, and so many students, they do not know exactly the definition of solubility. So firstly, I would like to explain what is solubility. You see, students know that there are three types of solutions: unsaturated solutions, supersaturated solutions, and saturated solutions. Saturated, unsaturated, and supersaturated. The term solubility relates with saturated solutions only. Okay, and we define the solubility term in this way: the concentration of a solute in a saturated solution at a particular temperature. So that is known as solubility. We have to express a temperature because variation in temperature varies the solubility values. Okay, and solution must be saturated. So again, I am repeating: the concentration of a saturated solution, concentration of a solute in a saturated solution at particular temperature is known as the solubility. For example, we know the solubility of salicylic acid in water at room temperature, it is about 0.3% above. It means 100 ml of saturated solution of salicylic acid in water at room temperature contains about 0.3 gram of salicylic acid. So this is means in this way we define the term of solubility. There are different methods of solubility enhancement if the drug has got poor solubility in water or in any other solvent. We employ different common methods like surfactant solubilization, complexation, the co-solvency, role of pH, salt formation, or you may say derivatization and all that. One of the method of solubility enhancement is hydrotropic solubilization also. So that hydrotropic solubilization I will discuss in afterwards. Then initially I would focus on the mixed solvency concept. As you are reading on your slide, novel, eco-friendly, and economic applications of mixed solvency concept in pharmaceutical sciences. So this mixed solvency concept, particularly in this concept, we employ the solvent character of solids for solubility enhancement. Up to this time, our books they say that whatever the matter exists in the form of liquid, they all are known as solvent. But today in your this lecture, you will find that solids also have got solubilizing power. And of course, the students, you can note down my this mobile number, which is WhatsApp number also, and email ID for any query if it is not solved today at the end of the lecture. So in future also, you may contact me by any of the and these means either WhatsApp number or email ID. Of course, there is one website also, www.rkmaheswari.com. On this also, you will find so many things related with hydrotropic solubilization, mixed hydrotropic solubilization, and mixed solvency concept. Now, this is second slide. What I would like to tell you here by this slide, scientific matter on mixed solvency concept, hydrotropic solubilization and mixed hydrotropic solubilization is also available in the form of RKM lecture series 1 to 31. 1 से लेके 31 तक YouTube पर है, and for every YouTube of these, the duration is about 14-15 minutes. So those who are interested in some of the things, they can note down the RKM lecture series. I will quote there. I will tell you the numbers of RKM lecture series for which they can see it depending on their topic of interest. And of course, there are two RKM audios also, 1 and 2, but they are not available directly on YouTube. Okay, means you can ask me, I can send it to you. For future, you may say the correspondence. Okay. Now, mixed solvency concept was proposed by me, Dr. R.K. Maheswari, in 2009. Okay, copy was started by me in year 2008. Okay, of course, hydrotropic solubilization is about 100 years old. In year 1916, the term hydrotropic solubilization was started by some scientists like Newberg, etc. Okay, but working on hydrotropy, I have started, of course, before 2008, only the single hydrotropic solubilization was being used by the scientists, but now from 2008, you will have means matter on mixed hydrotropic solubilization. Now, firstly, I would like to tell you now the mechanism is a very simple mechanism of dissolution. What happens in dissolution? When you dissolve something in a solvent, for example, if you dissolve sodium salicylate or ascorbic acid or dextrose in water, what happens? This dissolution involves hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. Means, suppose your solute is sodium salicylate, you are dissolving in water. So why it gets dissolved in water? Because the molecules of water and molecules of sodium salicylate in these between these two molecules, means sodium salicylate molecule and water molecule, there is hydrogen bonding and weak van der Waals force because of which the dissolution is there. So it is very simple mechanism. In place of solvent molecules, molecules of solid and molecules of gas may also be there. This is new thing to understand. What is this new thing? When the molecules of gas or molecules of solid, they are in liquid state, then they may also be involved in hydrogen bonding and weak van der Waals forces with the solute molecules. So this is the important thing to learn in this lecture. So I will focus on the utilization of solid particularly, but before that, we will learn something about the solvent, which I have told you that whatever the substances exist in liquid state at room temperature, they all are known as solvent. For example, water, glycerin, oils, propylene glycol, chloroform, ethanol, methanol, DMF, etc. No solvent is universal solvent. Means no solvent has good solubilizing power for all solutes. Say, for example, in case of water, we know from the books that about 1/3 of the, now I am reading from this only. Okay, for example, we know that about 40% of the drugs, they are water soluble. Means they have got good solubility, which 40% drugs, they have got good solubility in water, and about 60% drugs, they are water insoluble. So we can say For example, the water has good solubilizing power for some solutes and bad solubilizing power for other solutes. Good solubilizing power for 40% drug, bad solubilizing power for 60% drug, like this. Similar statement is correct for all the so-called solvents. Again, for example, chloroform possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. So whatever the name of any solvent you take, whether it is GMSO, DMF, acetone, methanol, chloroform, any solvent, they are good solvent for some solutes and bad solvent for other solutes. This statement we have to remember for clarification of the further matter which I am going to discuss with you. Okay. Now, mixed solvency concept, there are two parameters. Okay. So, number one parameter, it says each and everything present on the earth has got solubilizing power, whether it is a gas, liquid, or solid. Each matter is called solubilizer in this concept. Each solubilizer, whether it is gas, liquid, or solid, possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. So again, I am repeating the word, whatever the matter exists in this universe, whether it is gas, liquid, or solid, they all have got solubilizing power. And this is very new thing to you. Most of the students, they are listening first time from me that uh, each and every matter, whether it is your drug, whether it is your ibuprofen, flurbiprofen, naproxen, aceclofenac, paracetamol, etc., all substances possess solubilizing power. But how to utilize the solvent character of the solids, I will explain you in detail later on. Now, for the detail of this parameter 1, please refer RKM lecture series 01. I told you that on YouTube it is available. If you put the word RKM lecture series and if you click on number 1 YouTube this matter, then you will get the details of about 14-15 minutes of duration. Okay, so now coming to next point about the gases. Now, how can we say that gases have got solubilizing power? So I will explain this thing to you. The molecules of a gas may come in liquid state in two ways. You see, I told you that hydrogen bonding at weak van der Waals forces, when can they be applied? They can be applied only when the molecules are in liquid state. Okay. So if the gas comes, the molecules of gas come in liquid state, then definitely the molecules of gas may be involved in hydrogen bonding and weak van der Waals forces with the molecules of its solute. So how can the molecules of gas may come in liquid state? By two methods. Number one, by liquefaction of the gas. For example, if we liquefy a gas, molecules of a gas come in liquid state and can be involved in hydrogen bonding, weak van der Waals forces with molecules of a solute. In supercritical fluid technology, carbon dioxide gas is liquefied at particular pressure and temperature. Solvent action of molecules of carbon dioxide is utilized for preparation of nanoparticles or extraction of active constituents from herbal powder or purification of compounds, etc. However, liquefied carbon dioxide gas has poor solvent action for some solutes, and hence we have to add other solvents like ethanol, methanol, etc. This proves that liquefied carbon dioxide gas possesses bad solubilizing power for other solutes. I am again explaining this thing to you. In supercritical fluid technology, which is already exists at this time also. Of course, it is a costly method, but in this technology, what happens? CO2 gas, when it is liquefied, it is used for its solvent action for making a nanoparticles, extraction of active constituent, etc. But this liquefied CO2 is also not good solvent for each and everything. How do we know this? Because sometimes to increase the solvent character of liquefied CO2 gas, we have to add other co-solvents like methanol, ethanol, etc. Okay, so in short, we can say liquefied CO2 is good solvent for some solutes where we do not employ co-solvent. So liquefied CO2 is good solvent for some solutes and bad solvents for other solutes. Means for which compound where you have to apply co-solvent to improve the solvent character of liquefied CO2. So what is happening here? After liquefaction, the molecules of carbon dioxide, they are coming in liquid state, and now they may be involved in hydrogen bonding and weak van der Waals process with the molecules of solutes. That's why liquefied CO2 is demonstrating its solvent character. Similarly, if you liquefy any other gas, say nitrogen, helium, oxygen, then also the molecules will come in liquid state and they may be involved in hydrogen bonding, weak van der Waals process, and they may so demonstrate their solvent character for some solutes. But I told you that utilization of gases for solvent character, it is a costly matter. That's why I've explained you in this way the molecules means by liquefaction the molecules of gas come in liquid state. Okay. Now another method how the molecules of gas may come in liquid state by dissolution of a gas in a solvent. Molecules of gas may come in liquid state by dissolution in a solvent, and then the molecules of a gas may be involved in hydrogen bonding, weak van der Waals forces with molecules of other solutes. Example, concentrated HCl, concentrated hydrochloric acid is such example. The molecules of HCl gas come in liquid state after dissolution in water. Solubility of nalidixic acid in concentrated HCl is about 5%. The solubility of nalidixic acid in water is about 0.021%. Now I am explaining this point. Now you see in first point we have seen that if you liquefy a gas, the molecules come in liquid state. This is another method by which the molecules of gas may come in liquid state is by dissolution of gas in a solvent. So what is the example here? HCl gas. HCl gas, when it is dissolved in water to make concentrated HCl, the molecules of HCl come in liquid state. Okay, and now these molecules, HCl molecules, may be involved in hydrogen bonding weak van der Waals process with the molecules of solute like nalidixic acid. So that's why the solubility of nalidixic acid is very high solubility of nalidixic acid is there in concentrated HCl. Okay, and both are acids, so there is no role of pH. Means what is happening here? Hydrogen bonding, weak van der Waals forces between the molecules of nalidixic acid and molecules of HCl. That's why there is high dissolution or high solubility of nalidixic acid in concentrated HCl. Okay, so this is the example. Now about the solids, means liquids, these gases by liquefaction or by dissolution in a solvent, the molecules come in liquid state. Now we have to see how the molecules of a solid may come in liquid state. The molecules of a solid may come in liquid state by three ways, three methods. Number A, by melting; B, by dissolution in a solvent; C, by eutectic formation. Now I will give example of all these A, B, C. Once the molecules of solid come in liquid state, the molecules of solid can be involved in hydrogen bonding, weak van der Waals forces with the molecules of solute. Okay, so this we are going to learn in this later on here in other slides. A, melting. By melting means the molecules of a solid may come in liquid state by melting. So molecules of solid may come in liquid state by melting. The example is melted urea, a clear colorless liquid at about 132 degrees centigrade, which is the melting point of urea. So when urea melts, we get a clear colorless melted urea. It has got good solubilizing power for dichloroflex sodium. The melting point of dichloroflex sodium is 283 degrees centigrade. Why I have given here the melting point of dichloroflex sodium? The reason is, do not think that the dichloroflex sodium might have melted at 132 degrees centigrade. No, there is quite difference between the melting point of these two solids. So there is no melting of dichloroflex sodium at 132 degrees centigrade of melted urea. So what we are seeing here, the melted urea acts as solvent good solvent for dichlorofenac sodium. Of course, if you cool down the mixture, it will solidify. So I am not talking about the low temperature. I am talking about the temperature 132 degrees centigrade at which urea is in melted condition. The molecules of urea are available in liquid state at 132 degrees centigrade, and they are involved in the hydrogen bonding and weak van der Waals forces with the molecules of dichlorofenac sodium. That's why it gets dissolved. Suppose there was no solvent action in melted urea, then you could have obtained a suspension of dichlorofenac sodium in urea, but you are getting a solution. So this proves that after melting, urea molecules have come in liquid state, and because of hydrogen bonding weak van der Waals forces, there was dissolution of dichlorofenac sodium in melted urea. Okay, this is just, please note it down. This is just proof that melted solid has solvent action. Do not relate with process form. So please do not ask such type of question that sir, urea will be toxic, because I told you this is just a proof. I am not saying you that you use in formulation. This urea you are not going to use in formulation, but just it is a proof, because we should know that how can we say that solids have the solubilizing power like this. So these are just the proof. Number two example, 1 gram clear colorless melted phenol at about 44 degrees centigrade, which is the melting point of phenol. It dissolves about 500 milligram of nalidixic acid. Melting point of nalidixic acid is 230 degrees centigrade, which says that nalidixic acid has not been melted at 44 degrees centigrade, which is the temperature of melted phenol. Means, okay, so in this now, means melted phenol has very good solubilizing power for nalidixic acid. 500 milligram per gram of melted phenol means about 50%, 40-50% solubility is there, means very high solubility of nalidixic acid in melted phenol. Phenol is solid at room temperature, all of us know. Okay, we all know that it is a solid at room temperature, but at its melting point, it dissolves, it acts as very good solvent for nalidixic acid. Okay, so this is just a proof. Please do not relate with formulations and don't ask question on the formulation part using phenol like this. These are just the proof. So here in this slide, A melting, what we have seen that by melting also the molecules of solid come in liquid state, and they may be involved in hydrogen bonding weak van der Waals forces with the molecules of solid. Solute. So in this way, melted molecules of phenol have come in liquid state, and they are dissolving nalidixic acid because of hydrogen bonding and weak van der Waals forces like this. Now, so number one means A was by melting the molecules of solid coming in liquid state. Now B, by dissolution in a solvent, means how the molecules of solid may come in liquid state. Another method is means B, by dissolution in a solvent. Molecules of a solid may come in liquid state when the solid is dissolved in a solvent. For example, number one, solubility of ibuprofen in water is 0.028%, means very limited solubility and a poorly soluble. Ibuprofen is poorly water soluble drug, very poor solubility is there. But if we prepare 2 molar sodium benzoate solution, means 28.8% weight by volume sodium benzoate solution, the solubility in the solution of sodium benzoate, which is known as hydrotropic solution, the solubility is 2.390%, which is about 85 times. Means if you divide 2.39 by 0.028, it is about 85. So there is 85 times solubility enhancement in this solution of sodium benzoate. Okay, so why? Again, the reason is the molecules of sodium benzoate have come in liquid state after dissolution, and now they are involved in hydrogen bonding and weak van der Waals forces with the molecules of ibuprofen. That's why there is high solubility of ibuprofen in this sodium benzoate solution, which of course this is a the so-called hydrotropic solubilization. We will discuss in detail later on. Okay, but what we are seeing here is solid sodium benzoate. The molecules come in liquid state after dissolution, and they are responsible. Means molecules of sodium benzoate are which have come in liquid state. They are responsible for solubility enhancement of ibuprofen. Now another example, solubility of furosemide in ethanol. Now here we are discussing another solvent, ethanol. So solubility of furosemide in ethanol is about 1.7% weight by volume, means it is sparingly soluble. Furosemide is sparingly soluble in ethanol. Now, the solubility of furosemide in ethanolic solution of niacinamide 15% is 5%. Means if you prepare 15%, 15% niacinamide weight by volume niacinamide solution in ethanol, in this solution, the solubility of furosemide is about thrice, 3 times solubility enhancement is there. Means that is about 5% now. Why there is increase in the solubility? The reason is the molecules of niacinamide, which is solid at room temperature, have come in liquid state after dissolution in ethanol. And now the molecules of niacinamide are available in liquid state, and now they are involved in hydrogen bonding and weak van der Waals process with the molecules of furosemide, and that's why there is more dissolution of furosemide in solution. So, okay, now number 3. Solubility of pyroxicam in propylene glycol. This is third solubility here example. Third example, propylene glycol. Here, the solubility of pyroxicam is about 5 milligram per ml. About 5 milligram per ml in propylene glycol, pyroxicam. But if we prepare 10% weight by volume sodium acetate and 10% sodium caprolate weight by volume in propylene glycol, means total 20%, means 10 per means a solution contains two solids, 10% sodium acetate and 10% sodium caprolate in propylene glycol. Okay, combinedly means 20% solid content is there. These are the sodium acetate and sodium caprolate, which are solid at room temperature. Now the molecules of sodium acetate and molecules of sodium caprolate, they have come in liquid state in a solution in propylene glycol, and now they are responsible for hydrogen bonding and weak van der Waals forces with the molecules of pyroxicam. That's why you are getting high solubility, about 120 milligram per ml. 120 milligram per ml is the solubility because of the presence of the molecules of these solids, two solids. Okay, so how much times solubility enhancement is there? 120 divided by 5, about 24 times solubility enhancement is there. Why? Because of these two solids. Okay, so these are all the proof that by dissolution also the solid molecules may come in liquid state and they are involved in hydrogen bonding and weak van der Waals forces. Okay, now the third method, A was by melting, solid molecules come in liquid state, B was by dissolution, and C is by eutectic formation. How? Menthol and thymol, if you take in equal ratio, which suppose you take 10 gram menthol, 10 gram thymol, you triturate in pastel mortar. With the help of pastel mortar, you get a clear colorless eutectic liquid. Of course, this is given in books also. So there is a eutectic liquid of menthol and thymol at room temperature. Okay. Now, so what happened here? The molecules of menthol, which is solid at room temperature, and molecules of thymol, which is solid at room temperature, they have come in liquid state, okay, in this eutectic liquid, and it is a clear colorless liquid. Eutectic liquid is clear colorless liquid. Now, example, solubility of metronidazole benzoate, which is poorly water soluble drug. Metronidazole benzoate is very poorly water soluble drug, but here you see the solubility of this metronidazole benzoate is about 200 milligram per ml in this eutectic liquid. About 200 milligram is about 20% is the solubility. Means very high solubility of metronidazole benzoate in this eutectic liquid. What is happening here? The molecules of menthol and molecules of thymol, they have come in liquid state and they are responsible for hydrogen bonding, weak van der Waals process with the molecules of metronidazole benzoate. That's why there's high solubility of metronidazole benzoate. Of course, do not relate with formulation please. No need to, we are not making any formulation, but we are saying the proof only. So do not relate with formulation, the toxicity of menthol, thymol, no, because these are just the proof that the solid, they come in liquid state, the molecules come in liquid state by eutectic formation. Okay. Now number 2, solubility of salicylic acid is about 70 milligram per ml in this eutectic liquid, which is about 77%, is very good solubility. In water, I told you that in water the solubility of salicylic acid is about 0.3%. But here in this eutectic liquid, about 7% is the solubility, is good solubility. Now the reason is again the same. The molecules of menthol, molecules of thymol, they come in the liquid state, and they are responsible for the dissolution of salicylic acid because of hydrogen bonding with van der Waals forces. Okay, suppose there was no solvent character in this eutectic liquid, means in this menthol thymol, then we could have obtained the suspension of salicylic acid in this eutectic liquid, the suspension of metronidazole benzoate in this eutectic liquid. Okay, so in this way, it is proving that the molecules of solid, they are being involved in dissolution because of hydrogen bonding with forces. Number 3, now you see solubility of aspartame is less than 5 milligram per ml in this eutectic liquid. Aspartame. Here, what we are seeing, very poor solubility of this aspartame is there in eutectic liquid. So we may say that for aspartame, this eutectic liquid is poor solvent, and for salicylic acid in metronidazole, it is a good solvent. Okay, so here we can say this eutectic liquid is good solvent for some and bad for other. Anyway, I think in further also slides we will see the detail of this. But RKM lecture series 8 YouTube, if you see this, about 14-15 minutes video is there. You will see the detail in this also. Yes, and now you see here in this eutectic liquid, which I told you, menthol thymol 1:1, pH is 6.5. Just for information, it is nearly neutral. Now, if you see left-hand column, compounds having good solubility, metronidazole benzoate, good solubility, atenolol, ardanazole, benzocaine, etc. For all these compounds, this eutectic liquid is good solvent. And for right-hand side column, cetronidazole, furosemide, aspartame, etc. For these, it is poor solvent, this eutectic liquid. Okay. One thing again, not to relate with formulation. Again, please take it carefully. Just these are the proof. And similarly, if you take thousands of compounds, you see the solubility in this eutectic liquid. Some of the compounds will fall in left-hand column, and some of the compound will fall in right-hand column. So that you can say this eutectic liquid is having good solubilizing power for some solute, left-hand column, and bad solubilizing power for other solute, right-hand column. So in this way, it has been proved that this eutectic liquid is a solvent, although it contains two solids, menthol and thymol. So this means it has got solvent character. Okay. Now again, you see some of the liquids, the solubility of some of the liquids, eutectic liquid mixture, thymol, menthol, and the same eutectic liquid we are discussing. If you see the right-hand column, glycerine and water, they are immiscible in this liquid, means they are, you may say, they are insoluble. Glycerine is insoluble in this eutectate, water is insoluble. Now you see left-hand column, ethanol, propylene, glycol. For all these liquids, it is good solvent. Okay, similarly, if you check other hundreds of liquids, some will fall in right column and some will in left, like this. So, in short, you can say this eutectic liquid is good solvent for some solute and bad for other. So, it has been proved that it is a solvent, and once it is proved that it is solvent, means thymol and menthol, they also contain the solvent character. Okay. Now, coming to individual compounds, melted menthol. You see, your eutectic was containing two things, menthol and thymol. We are discussing about one of the component, which is menthol. Melting point is 44 degrees centigrade. If you melt this menthol, which is solid at room temperature, if you see the solubility, so left-hand column says that for ibuprofen, salicylic acid, metronidazole, benzoate, etc., it is good solvent. Okay, 1 gram of melted menthol dissolves 600 milligram of ibuprofen to 200 milligram of salicylic acid, like this. So for these compounds, it is good solvent. Please do not relate with formulation, just prove. Okay. Now, if you see the solubility of aspartame, pyroxene, etc., for this melted menthol is poor solvent. Similarly, if you check so many compounds, some will fall in left column, some will fall in right column. So you may say that melted menthol is good solvent for some solute, left hand column, bad solvent for other solute, right hand column. So in this way, it is proved that melted menthol has got solvent character. Suppose there was no solubilizing power in menthol, then all would have fallen in right hand column. Means all would have resulted in the suspension. Okay, do not relate with formula. Similarly, melted thymol, melting point 44 degrees centigrade. It is good solvent for some solute, left hand column, bad solvent for other solute, right hand column. Okay, like this. And if you check others, some will fall in left column, some in right hand column, like this. Do not relate with formulation. All these are the proof that solids have got solubilizing power. Another proof that solids have got solubilizing power, phenol water system. Those who have forgotten this, you please listen from me. Phenol below 8% and above 70%. they are clear solution. What does it mean? Suppose you take 5 gram phenol and 95 gram water, you will get a clear solution. If you if you take 95 gram phenol and 5 gram water, then also it is a clear solution. But in between these means 8 and 70 means you cannot prepare 50% phenol solution in water, it will be turbid. You cannot prepare 40% phenol in water solution, no, it will be turbid. Okay, we are discussing about two solutions, 5 gram phenol, 95 gram water, clear solution. Here phenol is a solute and water is a solvent. Okay, now if you take another solution, 95 gram phenol, a large quantity of phenol, 95 gram phenol, plus 5 gram water, again a clear solution. Here, water is solute and phenol is a solvent. Phenol is a solvent. So here, it itself says that phenol, which is a solid at room temperature, it is a solvent. Okay. This proves that solid has solvent action. Oxalate apparatus can be run by phenol like just like solvent. As you use the solvent and oxalate apparatus for extraction of active constituent. I have tried this phenol, means oxidation by phenol. Phenol was in groundwater flask, vigorous boiling, vapors were going, and they were condensed extraction chamber. And I used three type of compounds. Number one, turmeric powder in a cotton bag. Okay, so yellow matter was extracted out by siphoning and all that. And similarly, peanut oil was extracted from peanut powder. Similarly, sesame oil was extracted from sesame seed. Okay, I am not saying to you that to operate oxalate apparatus by phenol, but just I am giving the proof that when phenol can be used for oxidation and there can be extraction by phenol, this means it is a solvent. Just for proof, I am saying, okay, those who want to utilize the phenol, the solvent character of phenol for extraction, please contact me later on because I have got very limited time here, so I cannot give all the details. But of course, you please note down RKM lecture series 3. This gives about this phenol water system and all that. Now, mixed solvency concept, second parameter. Up to this time, we were discussing first parameter of mixed solvency concept. The first parameter says that each and everything present on the earth has got solubilizing power. Each and everything means what, whether it is gas, liquid or solid, all possess solubilizing power. Now, second parameter. Second parameter relates with the formulation. We can prepare the formulations in safe way by the solubilizing power of additives. So I am giving one example here. Actually, what I want to focus here is we want to utilize the solvent character of additives which are involved, which are used in for various formulations in pharmacy, means pharmaceutical formulations. We are employing smaller concentrations of different additives. Why? Because we know when each and everything has got solubilizing power, means whatever the additives we are using, whether in the tablet or solutions or injections or ophthalmic formulation or anywhere where you are using the additive, though the solvent character of additives can be employed to increase the solubility. Why we want to employ additives? Why not we are going on co-solvency or you may say the surfactant solubilization or this complexation or rule of pH and all that? Because if you imply any of these methods or hydrotropic solubilization, single hydrotropic, no. Why? Because when we imply any of these, for example, a surfactant or co-solvent, a large concentration of surfactant or large concentration of co-solvent or large concentration of hydrotropic agent can be toxic for human being or animals, you may say. So in place of large concentration of single solubilizer, if we imply smaller concentrations of several solubilizers, making a concentrated solution, then definitely if you can increase the solubility, then they can be safely employed in your formulation so that your formulation will be safe. So just this is one example here. You please see it. This is the aqueous solution containing 4 solid solubilizers. 4 solid additives, 4 solid solubilizer. You see, in mixed solvency concept, each and everything is known as solubilizer. As all the liquids are known as solvent, Whatever the name of any solvent you take, it is good solvent for some and bad for others. In the same way, although all substances are known as solubilizer in this fixed solvency concept, but whatever the name of any solubilizer we take, it is having good solubilizing power for some solute and bad solubilizing power for other solute. So remembering this thing in mind, now you see here the application of mixed solvency concept, second parameter in the formulation. What I have done, I have made a aqueous solution containing 4 solid solubilizers, or you may say 4 solid additives. Sodium benzoate 5%, it is safe. For sodium caprolate 5%, it is a nutritional agent. It is also same safe. Yani, sodium citrate 5%, it is also safe. Polar summer 407, it is also safe. Okay, now so these 20% solution of these 4 solids was employed for to check the solubility of furosemide and pyroxicam in the solution. Now the results are here. Furosemide solubility in this blend, mixed solvent blend, is 35 milligram per ml, while the solubility of furosemide in water is less than 1 milligram per ml. You may assume 1 milligram per ml, and in this blend it is 35 milligram per ml. About 35 times solubility enhancement is there. Why? Because the molecules of sodium benzoate, molecules of sodium caprolate, sodium citrate, polaxamar 40, which are all of solid at room temperature, they have come in liquid state, and now they are responsible for hydrogen bonding, weak van der Waals forces with the molecules of furosemide. That's why you are getting a high solubility of furosemide in water. Okay. Now here, one thing you might have noted is the pH of this solution is 7. So don't think it is a rule of pH. No rule of pH. It is just the rule of solid as solvent. Okay. Now another example is that of pyroxicam. The solubility of pyroxicam in water is about 1 milligram per ml. And in this blend, the solubility is about 20 milligram per ml in this blend. About 20 times solubility enhancement is there because of these 4 solid solubilizers or 4 solid additives like this. Now for the detail, please refer this explain since the time is less. So anyway, I am now just coming. 45 minutes over. Okay. Okay. Now briefly, I will explain the application of mixed solvency concept, which is very new to you. You can employ mixed solvency concept to make dry powder injection for reconstitution of poorly water soluble drug. Dry powder injection for reconstitution of poorly water soluble drug. For 1 ml injection of candid sultan acetyl, which is poorly water soluble. Okay, it's the solubility in water is very less. You cannot make 8 milligram per ml in water the solution of this candid sultan acetyl. But with the use of 3 solid solubilizers, sodium caprolate, sodium benzoate, and sodium acetate, the concentrations given in the brackets, you can make the dry powder injection on the reconstitution. On reconstitution, you will get a clear solution. If a paper has been published, those who want to see the details of this, please refer RKM lecture series 19. Okay, and those who forget these numbering and all that, please contact me. I will tell you. So many things. They are, of course, they are available on website also. Okay. Now coming to application of mixed solvency concept to make solid dispersion for fast dissolution of poorly water soluble drug. So please see YouTube RKM lecture series 17 for this. Furosemide drug, which is poorly water soluble drug, 2.5 gram. Sodium citrate 1.25 gram, sodium acetate 1.25 gram, beta cyclodextrin 2.5 gram, sodium caprolate 5 gram. These 4 solids were employed to increase the solubility of this, and then the solution was made in this aqueous solution that of furosemide, and then water was removed by heating and drying was done. So you got a solid dispersion which has got very quick or very fast dissolution of furosemide in water. Paper is published, and for this paper, if you want, you see just RK lecture series 17. Now, mixed solvency concept for liquid solid system. We can make liquid solid system which are similar to the solid dispersions. Number 1, solubility of pyroxicam and propylene glycol is less than 5 milligram per ml, and the dose of pyroxicam is about 20 milligram per tablet in market. So for 20 milligram, you will need about 4 ml of the propylene glycol. 4 ml is about 4 gram. So 4 gram, then adsorbent, so about 15 gram or 20 gram total. So you cannot make a tablet or capsule. But with the help of mixed solvency concept, What you can do, you can increase the solubility of pyroxychem in this propylene glycol. So here you are seeing the example. The two solids, sodium tetrahydride, which is nutritional agent, 10%, and sodium acetate, 10%, which is also solid at room temperature. So 20% solution of these two solid solubilizers or solid additives were employed to increase the solubility of pyroxychem in propylene glycol that goes up to 120 milligram per ml. Okay, so details of this you please see RKM lecture series 20. What happens in this way, by solubility enhancement, you can reduce the volume of the solution required for 20 milligram of the drug, and then after adsorbent you can prepare as a tablet and capsule, etc. Okay, so please see RKM lecture series 20. Okay, now this is of course given 100 milligram pyroxychem plus 1 ml blend. This is the example here, plus microcrystalline cellulose adsorbent. Aerosol was used as a lubricant for 5 tablets, 20 milligram pyroxychem each. Okay, so in this way you means you are able to make solid you may this tablet or capsule of this poorly water soluble direct for the fast of the fast dissolve. The paper has been published. Please refer RKM lecture series 20. Now coming to the application in aqueous injection. So for this dichloromethane sodium injection was made at rate of 75 milligram per ml using mixed solvency concept. RKM lecture series 25 will give the details of this. Otherwise, the solubility of dichloromethane sodium in water is such that you can prepare only 25 milligram per ml. But with the use of solid solubilizer, you will find in this paper published 75 milligram per ml injection, means a concentrated solution of dichloromethane sodium injection in the form of injection can be made. Okay, second example is that of hydrotropic injection, which is a poorly water soluble drug. RKM lecture series 28. If you see, you will see the details of solid solubilizers, solubilizers employed for increasing the solubility of hydrotropic. Paper is published. Now another mixed solvency concept can give you a method to have innumerable safe solvent system by mixed solvency concept. So please listen this carefully. Very useful concept of mixed solvency concept. Here detail you will find in RKM lecture series 15. RKM lecture series 15. Now what has been explained here, the sum of the additives which are employed in injections are given in this. They have been taken from the theory and practice of industrial pharmacy by Lakeman book. Lakeman book is known to so many students also. So in the parenteral chapter, or you will say in the injection chapter of Lakeman, you will find that benzyl alcohol is used 5% as preservative and local anesthetic. What we are discussing, the additives which are employed in making the injections. Now another additive, PG4000, which is solid, 3% as suspending agent, sodium citrate 4% as buffering agent for injections, sodium benzoate 5% as buffering agent for injection, theophylline 5% as stabilizing agent against precipitation, propylene glycol up to 50% co-solvent as co-solvent, glycerine up to 25% co-solvent. These all are additives. Ethyl alcohol up to 49% co-solvent, PG300 up to 50% co-solvent. HB beta cyclohexane, this is not from Lakeman, but this is given in IIG. IIG means inactive ingredient guide, which is followed by the industries to refer the highest concentration of the solubilizer which can be employed for formulation. So if you refer this inactive ingredient guide, then you will find that HB beta cyclohexane can be used up to 10% in the formulations. And injection. Polaxamar 407 can be used up to 15% as per IIG. Okay. Now, so these, whatever these you are saying, these are some of the additives which are employed in injection safely, which are employed safely. Now, what you have to do, you can make innumerable safe solvent system out of these only. Now, see for example, blend A. Suppose you take benzyl alcohol 5%, sodium benzoate 5%, theophylline 5%, propylene glycol 5%. One blend is ready. Now this may increase the solubility of some of the poorly water soluble drugs. If you see blend B, sodium benzoate 5%, ethyl alcohol 5%, cyclohexane 5%, PG 305%. This is another blend. It has got different solubilizing power. Blend C, sodium benzoate 5%, propylene glycol 5%, flux output 5%, benzyl alcohol 5%. This is third blend. So this has got different solubilizing, means all A, B, C, they will have different solubilizing behavior for they will demonstrate different solubilizing behavior for different solutes. Okay, in this way, by permutation combination, you can make innumerable safe solvent system. Why I am using this word safe solvent system? Because whatever the concentrations you have employed, they all are in safe limit. Okay, and when you will perform the toxicological study, you will mostly you will find the preparations will be safe. So for this, please see RKM lecture series 15 for the details. So in this way, you can have innumerable safe solvent system. Now, another application of mixed solvency concept to make vaginal film of poorly water soluble drug using mixed solvency concept. Here, the work was MPR project on metronidazole vaginal film using safe additives which were employed to improve the drug loading in vaginal film, particularly the solid solubilizers were employed for drug loading so that you can have a less small size of the film. Paper has been published, RKM lecture series 27, see for the details. Now here, improvement of drug loading in SEDDS, self-emulsifying retrieval system using the solvency concept. Paper is published, the drug taken was candicertan lexatil. By use of solid solubilizer, there was high drug loading, reduced concentration of surfactant and co-surfactant and all that. Please see the detail in RKM lecture series 29. Mixed solvency concept to improve the drug loading in oral films using mixed solvency concept. Here the work is that on this on dense cetron hydride drug, water soluble drug, solubilizing properties of additives were employed to increase the drug means poorly water soluble drug loading in oral films to reduce the size of the oral film. Of course, we imply the solid solubilizer to increase the solubility. Paper has been published. Please see RKM lecture series 30 for this. Now, some new things to you. Melted solids as solvent. Now you see here, of course, in short time I cannot explain this fully, but what I want to tell you that, say for example here, benzoic acid, it has got melting point of 122. It can be removed, means benzoic acid can be removed completely at 140 degrees centigrade in oven within 1 hour. Okay, I think I should leave this, otherwise it will take a lot of time. Anyway, but you see, this will give the all detailed extraction of active constituents using solvent action of solid. So reference is there, eco-friendly extraction using solid. Here, what we have employed, the solvent character of solids has been employed for extraction of active constituent, which was sesame oil from sesame seed powder. So you please refer this paper. This will give all the details that how can you imply the solids for their solvent character without the use of solvent. You can extract out the active constituent from herbal powders. Okay, now the results of extraction studies in this paper. Melted thymol, when it was used as solvent, this was the yield and all that. 50% thymol in ethanol was used to improve the solvent character of ethanol for sesame oil and all that. But we have very limited time. But such type of work has also been done to demonstrate the solvent character of solids. Now suggestions. Then of course this is not the end. I will start another slide. So now, since all compounds possess solubilizing power, we should try to use nutraceutical, proteins, amino acids, herbal harmless constituent, protein, vegetable juices, etc., to enhance the solubility of poorly water soluble drug to develop different pharmaceutical dosage forms. What I want to say you, such types of whatever the names I have incorporated here, they can also be employed for to demonstrate their solvent character for the solubility enhancement. Since there are no mathematical formulae for solubility enhancement, hence we have to try them by trial and error method. One thing, please listen, all the audience, I request you just you see by trial and error this can be done. So please don't make such type of question that, sir, do you have any systematic method for solubility enhancement? No, I don't have any systematic method, but at random by trial and error all these things were done. Okay. Now we mixed solvency concept. These are the details for other things. Of course, these are the miscellaneous list. Enumerable eutectic liquids can be, means this is a reference for RKM lecture series. So anyway, just I'm leaving this. Not thank you. I have to escape from my another slide I want to show you now. देखो खुश हो जाएंगे. Now you see, after mixed solvency concept, now for about 10 minutes, 15 minutes, I would like to tell you the utilization of hydrotropic solubilization and mixed hydrotropic solubilization in pharmaceutical sciences. Without the use of organic solvent, without the use of harmful organic solvent, you can do so many things. Okay. Again, those who are interested, again they can note down my WhatsApp number 94066 21907, email ID rkmaheswari@yahoo.co.in, and of course you may see the website also www.rkmaheswari.com. Okay, now coming to first slide here, firstly you please see how the organic solvents, they are how much harmful they are to human being and animals. Now we see here benzene, it is carcinogenic. Carbontetrachloride, it is toxic and environmental hazard, like this. So these are class 1 organic solvent. Actually, in this lecture now, in the later part of this lecture, I would like to demonstrate you, that means how can you minimize, or how can you remove, or how can you preclude the use of harmful organic solvent. This I am going to discuss. So before that, you should know what are the harmful effects of this solvent. Now class 2 organic solvent, acetonitrile, chloroform, hexane, methanol, toluene, so many solvents, they are quite frequently used in analysis and in formulation of novel drug system and all that. So I will tell you how can you minimize the use of these class 2 harmful organic solvent. Now here this is class 3, which is relatively safer. It is safer than class 2, it is safer than class 1, but then also it is not 100% safe, no. In this class 3 organic solvent, acetic acid, acetone, and you may see ethanol, ethyl acetate, and all that. Okay. No, so here these can be used, of course, but less frequently. Means I will tell you how to substitute all these. Now here the adverse effects of methanol. Now I will show you some of the harmful effects of some of the class 2 organic solvent, methanol. It is a class 2 organic solvent. Acute effects you are seeing here. Yes, you can read yourself. Or acute exposure of humans to methanol by inhalation, ingestion may result in visual disturbances, blurred or dimness of vision, leading to blindness, neurological damage, permanent motor dysfunction. Contact of skin with methanol can produce mild dermatitis. Okay, chronic effects, chronic inhalation, oral exposure to methanol may result in headache, dizziness, insomnia, nausea, gastric disturbances, visual disturbances, and blindness in human. So just like this, that of methanol, you see all these means this chloroform is also very injurious to our health. Similarly, your this DMF, dimethylformamide, is very injurious to our health. Then your toluene is also very injurious to our health. Then acetonitrile, again, methylene chloride, hexane, like this. Okay. Now I am switching over to hydrotropic solubilization, which is about 100 years old concept. Hydrotropic solubilization. Hydro means water. So this solubilization relates with the solubility enhancement in aqueous solutions only. Aqueous solutions में ही solubility बढ़ाने से संबंधित है ये. Not solubility enhancement in propylene glycol or glycerine or PG300 or chloroform. No, it is just, it relates with the solubility enhancement in aqueous solutions. Okay. Now these are the some of the hydrotropic agents: sodium salicylate, sodium benzoate, sodium citrate, sodium acetate, urea, niacinamide, etc. So these are the commonly some of the hydrotropic agents. Now to explain this hydrotropic solubilization, I will go example here. The solubility of a drug in hydrotropic solution, upon solubility of a drug in water, this gives the solubility enhancement ratio. How it is calculated? This is the example. Ibuprofen, 2 molar sodium benzoate solution means 2 molar means 28.8%. इसमें लिखा नहीं है स्लाइड पर 28.8%. Roughly you may assume it is a 30% weight by volume solution of sodium benzoate in water. This is one example of hydrotropic solution, sodium benzoate solution, 30% weight by volume. Here the solubility of ibuprofen in this solution is about 2.390%, 2.390%. And the solubility of this ibuprofen in water is 0.028%. So the solubility enhancement is 2.390 divided by 0.028, means about 85% fold solubility enhancement is there. Again, I am repeating, the solubility of ibuprofen in water is very poor, 0.028%, but solubility of this ibuprofen in this hydrotropic solution of sodium benzoate 30% is 2.390%. So about 85 times solubility enhancement is there because of this hydrotropic solubilization using sodium benzoate as hydrotropic agent. Now you see in the further list you will see 2 molar sodium benzoate relates with 28, means is equal to 28.8% weight by volume sodium benzoate solution. 2 molar niacinamide means 24.4%. 10 molar urea means 60% weight by volume urea. 1.25 molar sodium citrate means about 40%. 4 molar sodium acetate is about 33. Always you are seeing a concentrated solution is made. 24.4, 28.8, 60, 40, 33. These all are with a concentrated solution. Okay. Now here, if you see the solubility of ibuprofen in water, we have seen this, and sodium benzoate this. Now, if you see the solubility of chloroprofen in distilled water, 0.012%. But in 2 molar sodium benzoate means 28.8% sodium benzoate, 1.440, 120 fold solubility enhancement is there. Okay, naproxen in distilled water, 0.0019% solubility. 2 molar sodium benzoate means 28.8%, 1.081%, 120 fold solubility enhancement is there. Aspirin distilled water solubility, 0.131. 4 molar sodium acetate, 7.409. About 56 times solubility enhancement is there. So what you are seeing is these sodium acetate, sodium citrate, sodium benzoate, niacinamide, these all are hydrotropic agents. And when there is enhancement in large concentration of these hydrotropic agents, then we call this phenomena to be hydrotropic solubilization phenomena. So I am again defining the term hydrotropic solubilization. When there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent means hydrotropic agent, then we call this phenomena to be hydrotropic solubilization phenomena. Again, I am repeating, I told you that hydrotropic, hydro means water, वाटर में solubility बढ़ने से संबंधित है. So when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, means hydrotropic agent, then we call this phenomena to be hydrotropic solubilization phenomena. ये hydrotropic solubilization. Now I am telling you some of the methods where you can employ hydrotropic solutions to replace methanol, etc. Means toxic organic solvent can be replaced. So firstly, I will discuss eco-friendly titrated analysis of poorly water soluble drug using hydrotropic solution without using any organic solvent. Now see the example. Here you see the assay of furosemide drug API. API means bulk drug. Bulk drug means bulk drug is used to make tablet, injection, etc. In IP 2018, this is the procedure to perform for assay of furosemide API. Weigh accurately about 0.5 gram furosemide powder. Okay, then it is dissolved in 40 ml of DMF, dimethyl formamide, which is a class 2 organic solvent. After getting clear solution, then this the titration is performed with 0.1 molar sodium hydroxide using bromothiamyl blue solution as indicator. Okay, then carry out the blank determination. So from the point of view of students, I would like to tell you what is this blank determination. You will have to take 40 ml of dimethyl formamide in conical flask You will have to add few drops of bromothymol blue, and then you will have to use annual solution. How much annual solution is required for color change? Suppose it is 1 ml. So this 1 ml has been consumed by DMF for color change. This means in earlier solution also it would have been consumed this 1 ml for 40 ml of DMF. So this 1 ml annual solution, this will be subtracted from the original value. Suppose in previous titration it was 25 ml. Okay, NaOH solution. So 25 minus 1 ml means 24 ml has been consumed by drug. So this is known as blank determination. Okay, so here what we are seeing here, that dimethyl formamide, which is a class 2 organic solvent, okay, which is harmful for the human being. Now you may say why it is harmful and how it is harmful. Since it is volatile, it goes in your body during titrations and all that. Okay, so if we can replace dimethyl formamide by any suitable safe method, then better to replace dimethyl formamide. So again I am repeating, in IP 2018 they are using dimethyl formamide. Why they are using dimethyl formamide? Because the drug fusamide is poorly water soluble, so water cannot be used. In ethanol, it is sparingly soluble, so they could not use ethanol. Otherwise, ethanol was class 3 safer organic solvent. Okay, so what they have implied, a good solvent for fusamide DMF, which is class 2, of course, harmful. But because of good solvent character, DMF was employed for titration. Now, I am telling you a safe method, eco-friendly method, using hydrotropic solution. Weigh accurately about 0.5 gram fusamide API, dissolve in 40 ml of 30% weight by volume sodium benzoate solution, aqueous solution, which is hydrotropic solution. So because of hydrotropic solubilization, you get a very clear solution of fusamide in this 40 ml of 30% weight by volume sodium benzoate solution. Okay, then you will have to titrate this solution with 0.1 molar sodium hydroxide using bromothymol blue solution as indicator. Suppose you have got X volume of X ml of 0.1 molar NaOH solution. Okay, now blank determination. For blank determination, another conical flask, 40 ml sodium benzoate solution, few drops of bromothymol blue, you will see the color change. Suppose 1 ml of NaOH is required for color change, means this is blank reading. So 1 ml will be subtracted from X ml. So X minus 1 means X minus 1 ml of NaOH has been required for, has been used for titration of fusamide drug. So in this way, you get the assay of fusamide API in your bulk drug. So what you have done here, you have not used any organic solvent. What you have employed, 30% weight by volume sodium benzoate hydrotropic solution. The cost of this sodium benzoate solution is about rupees 40 per liter. How much? Rupees 40 per liter about. Okay, it is aqueous solution of sodium benzoate. Okay, now if you see the cost of DMF, it may be about 200 rupees per liter or 250 rupees per liter or so on so forth. Methanol is also costly. And main thing is they are very injurious to our health. So when we can perform the titration without the use of organic solvent, then why we should not use the hydrotropic solubilization? So in this way, you are seeing that just by the use of sodium benzoate, you can perform the titration. Another 100% correct result you will get. This has been shown in Indian Pharmaceutical Commission, Ghaziabad also. The analytical chemist of IPC, Indian Pharmaceutical Commission, from where IP comes. Okay, they have checked it. Means IP method has been checked and it has been compared with the hydrotropic method. There was no change. Now, the solubility of fusamide in 30% sodium benzoate solution is about 4.75%. It comes in soluble category. In soluble category, mein aata. Solubility of fusamide in distilled water is 0.064%, poorly water soluble. Because of the sodium benzoate hydrotropic solution, the solubility has been tremendously enlarged, and hence you are able to dissolve API in sodium benzoate solution to perform cytometric analysis. The cost of 30% sodium benzoate, I have told you, is about rupees 40 per liter. It is very safe. Means one thing, it is very safe. In case of organic solvent, when we have to dispose of from the companies or from the labs, then definitely they have to do certain treatments before disposing these such types of harmful organic solvent. But here there is no need of any treatment. You can throw the sodium benzoate solution as such without any treatment, no need. Assay of now another example, ibuprofen API, sorry, flurbiprofen. So in the same way, here ethanol. Just I am discussing in one minute. Ethanol here is used in IP 2018 for API assay, but it can be done with sodium benzoate solution without the use of ethanol. So again, it is eco-friendly method. Okay, cost I have told you. Now coming to naproxen. Here, the IP method involves in methanol, class 2 organic solvent, harmful organic solvent. Okay, this has also been checked by analytical chemist of Indian Pharmaceutical Commission, Ghaziabad, and same results they have found. Okay, now so preferably, I expect that in the coming issue of IP, that is IP 2022, maybe that hydrotropic method will appear in the assay, means without the use of organic solvent. Okay, so naproxen here with the use of sodium benzoate solution, it can be performed because the solubility of naproxen in sodium benzoate solution is tremendously enlarged, and you can dissolve the drug with the help of sodium benzoate itself. In the same way, salicylic acid. This you can see in your labs also. Students, B.Pharm, M.Pharm students, they can see in their colleges, because in colleges salicylic acid is always there, ethanol is always there. So they can compare the IP method where ethanol is being involved. Okay, it can be compared with sodium citrate hydrotropic method. Here, in place of sodium benzoate, what we are employing sodium citrate solution. This is also cheaper. This is also cheap. It is also not costly. Okay, so here without the use of ethanol, the salicylic acid titration can be done. This assay can be performed. Similarly, here ketoprofen API in IP 2018, it involves ethanol, but here in hydrotropic method, sodium benzoate can be used for its titration analysis. Then ibuprofen API use ethanol in IP method, but it can be done with sodium benzoate solution in the same way. Then this your ibuprofen tablet. Now you see here in IP 2018. Now see the procedure for the assay of ibuprofen tablet. Weigh and powder 20 tablets. Weigh accurately. The powder equated to 0.5 gram of ibuprofen. Extraction with chloroform. 3 times extraction is done, and evaporation of chloroform in air current. Chloroform is again class 2 organic solvent, and it is very harmful to us, our health. Dissolve the residue after removal of chloroform. Dissolve the residue in 100 ml of ethanol. This is another solvent, second solvent. Of course, it is a class 3, but then also it is not 100% safe. Okay, relatively safer than chloroform, but not 100% safe. Titration is done with NaOH solution. So here there is involvement of 2 organic solvent, chloroform and ethanol. But here in hydrotropic method, what you have to do without the use of ethanol, without the use of chloroform, just you have to weigh the powder equated to 0.5 gram ibuprofen. Shake briskly for 10 minutes with 100 ml of 30% sodium benzoate solution. During this 10 minutes shaking, what happens? Ibuprofen, which was present in tablet powder, gets dissolved in this hydrotropic solution. Then titration is done with NaOH solution. Break determination is done. So what you are seeing here, just by the use of sodium benzoate solution, you can perform the assay of ibuprofen tablets. So there is no need of chloroform, no need of ethanol. Now, other example of titanium ethyl vanillin, this can be done. These I have not done. Dimethyl formamide, anyone can do the analysis of ethyl vanillin, which involves DMF. It can be done with help of sodium benzoate. It can be tried. Indomethacin acetone is used. Sodium benzoate can be involved. Glibenclamide, ethanol. So you can replace ethanol. Chlorbromide, ethanol. Then these all are used in IP. Okay, so they can be replaced by hydrotropic with mefenamic acid. Ethanol is used. It can be replaced by hydrotropic solution. Now, after titematic analysis, now coming to UV spectrophotometric estimations of pharmaceutical dosage forms of poorly water soluble drug using hydrotropic solutions without using any organic solvent. Now, example, Trinidazole tablet IP 2018 method. It says weigh tablet powder equivalent to 0.15 gram of tindrazole. You have to dissolve with the help of 20 ml of methanol. Okay, and after dissolution, then volume is made up to 100 ml with methanol. So what you have done? 0.15 gram equivalent tablet powder and solution was made up to 100 ml with methanol class 2 RMS solvent. Okay, filter to remove water insoluble tablet excipient. Now 10 ml filtrate is taken and diluted up to 100 ml with methanol. Further 10 ml solution diluted up to 100 ml with methanol. Okay, then absorbance is taken at 310 nm against methanol. Then calculation is done using 356 as the specific absorbance, what you call E1% 1 centimeter value. So in this IP method of 2018 for tindrazole tablet, tindrazole is poorly water soluble drug. They have implied class 2 methanol, a organic solvent which is injurious to our health. Okay. Not only it is costly, but also it is injurious to health. Main thing is it is injurious to our health. Okay. Now they have employed methanol because tindrazole is water insoluble drug. In methanol, the solvent is more. That's why they have employed methanol. The total method is methanolic. Now you see, we can replace this methanol by hydrotropic solution. So weigh tablet powder equivalent to 50 milligram of tindrazole, add 20 ml of 30% aqueous sodium benzoate solution and shake for 10 minutes in a 25 ml volumetric flask. So what you have to do is you have to take tablet powder containing 50 milligram tindrazole, shake for 10 minutes with 20 ml of 30% bit by volume aqueous solution of sodium benzoate, which is hydrotropic solution. So during this 10 minutes taking, all the tindrazole which is present in tablet powder comes in the solution of this hydrotropic solution. Okay, then you have to make up the volume in a volume is made up to 25 ml with distilled water. Okay, now you please listen it carefully. What we have employed sodium benzoate solution only once. We are not making the volume with the sodium benzoate solution again. Once sodium benzoate solution has been used for extraction of your drug or for dissolution of your drug, further dilution is with distilled water only. So method is very cheaper. So up to 25 ml you have made the volume with distilled water now, and now this is filtered to remove water insoluble tablet excipient. Okay, then dilute 1 ml of filtrate up to 100 ml with distilled water. Again, here distilled water is used for dilution. Measure the absorbance of this solution at 318 nm against reagent blend. 318 nm here in aqueous system. In methanol, it was 310. But if you change the solvent, the peak is changed. This is known to so many students and all of us, of course. Okay, so here at 318 nm, we get the peak of tindrazole, and you have noted the absorbance against the reagent blend. Now, how the reagent blend is made, just from the point of view of the students, I would like to tell you. You see, reagent blend means such a solution which contains the same amount of sodium benzoate as is present in the sample solution with the drug. मीन्स जो ड्रग के साथ में जितना सोडियम बेंजोएट है उतना ही हमें रेफरेंस कबेट में रखना पड़ता है, जिससे so that there is neutralization of effect of the compounds which are present other than the drug. So how we will take 20 ml of 30% aqueous solution in a 25 ml clear and clean volumetric flask. Then volume will be made up to 25 ml with distilled water. Then now there is no need of filtration here. Now you will take 1 ml of this solution and dilute up to 100 ml with distilled water. So this solution contains the same amount of sodium benzoate which is present together with your drug. Okay, so in this way, the reagent blank against reagent blank, this will be kept in the reference cupboard. In the sample cupboard, you will keep the solution of drug together with sodium benzoate. So absorbance you have noted. Now, how to find out the amount of drug? Because here I have not given here the specific absorbance, or you can say even percent 1 centimeter. So it will be calculated like this. Calculate the content from the absorbance obtained by repeating the whole procedure using 50 milligram of tindrazole RS. RS means reference sample. Okay, sorry, reference standard in place of this tablet powder. तो आप क्या करेंगे? You have got a sample of known amount, means known purity of this tindrazole RS reference standard. So using this reference standard, you will make in the same way the solution. You will find out the absorbance, and from that you can calculate the quantity of tindrazole present in the tablet powder. Okay, if you cannot do this, so what you can do, you can make a elevation curve of your tindrazole using the same method, using 5, 10, 15, 20, 25 ml per ml. Then for 5 dilutions, you will use the 5 different reagent blanks, and you will note down the absorbance at 318 nm, and then you will plot a elevation curve that can be utilized to give the concerned amount of drug present in tablet powder. So ultimately, what you are doing is you are using sodium benzoate solution only. There is no involvement of methanol, no involvement of any organic solvent. Now, one thing I would like to explain to you how why we are able to perform all these things. The thing is same. Solids also have got solubilizing power, just like liquid solvent. Solids also have got solubilizing power due to hydrogen bonding with van der Waals forces. So these solids are also being involved in hydrogen bonding with van der Waals forces, and because of this, they are just dissolving your drug. Okay, and in this way you can perform the estimations. So without the use of any organic solvent, you may say with the use of solid solvent, you are able to perform the UV spectrophotometric analysis. Now you see other examples. Naproxen tablet, IP 2018 method involves methanol, class 2 organic solvent. This can be done. It has been done. And you can see my research papers also. So sodium benzoate has been used here. Indomethacin capsule, sodium benzoate has been used in place of methanol. Diazepam capsule, methanol has been replaced by mixed hydrotropic. Paper has been published here also. And of course, few more examples which are not given in this slide. Dichloride sodium. Its estimation in IP method involves methanol, use of methanol. It can be done by urea solution, hydrotropic solution of urea. Without the use of organic solvents, no methanol. Similarly, atenolol, methanol is used in IP method. It can be done by urea solution and all. So many things are there anyway. Now, one thing I would like to tell you, why sodium benzoate does not interfere at 318 nm of indazole P. The reason is sodium benzoate does not interfere above 292 nm के ऊपर interfere नहीं करता है. That's why at 318 nm of indazole it is not interfering. Urea does not interfere above 245 nm. और डाइक्लोरोफेनक सोडियम 276 nm पीक आती है. Okay, urea will not interfere in that estimation. Atenolol about 264 peak. There is no interference of urea. It can be used. Similarly, of course, these all in all these methanol is involved. So methanol can be replaced by these hydrotropic solvents. So many things can be done in this way. Now see the TLC using hydrotropic thin layer chromatography of drugs can be performed without the use of organic solvent. Now this is a paper which has been published, and this work has been done in Ujjain. Two Madam Garvita Joshi and Sonia Behlot, they took the interest, they performed this TLC in Ujjain, Mahakal Institute of Pharmaceutical Sciences. So reference is there. You can see the detail in this. So here just briefly I would like to tell you atenolol. IPM means IP method, Indian pharmaceutical method involves the use of organic solvent methanol. Okay, but here in PM proposed method using UR means urea, 30% midwife value equal solution of urea. This was the RF value. Similarly, in case of the same atenolol proposed method using sodium benzoate, 15% midwife value. This was the peak. There was no use of any organic solvent in these mobile figures. So now you can see all these details later on. So here paracetamol, urea solution and sodium benzoate without the use of organic solvent, caffeine, ibuprofen, no use of organic solvent, just by use of urea and sodium benzoate. The TLC was performed. Now you see another TLC, RK lecture series on YouTube. You see 10 number video. This gives the details of all this. So briefly, I will give you the here metformin hydrochloride, which is water soluble drug. 2% solution in water was made because it is water soluble. 2% aqueous solution was made for putting the spot on the TLC plate. TLC plate used was that of silica gel G. Okay, iodine chamber was used for identification of a spot. RF value was 0.66 using two hydrotropic agent in one solution, means mixed hydrotropic. 5% sodium benzoate plus 5% sodium citrate solution. This solution was used as mobile phase in the TLC of metformin hydrochloride. Identification, I told you, iodine chamber was used. This was the RF value. Guaifenesin 2% solution in water was used for spot. Silica gel G for plate. Iodine chamber for spot. RF value was 0.70. 5% sodium benzoate plus 5% neem-cinnamide solution. Mixed hydrotropic solution was used in mobile phase. There was no involvement of any organic solvent, and of course this was repeated so many times, so it is repeatability is there. Okay, similarly of course the coming to this again, इसमें वो पेपर का नहीं दिया, पब्लिश अभी हुआ नहीं है ना, हो गया, बहुत दिन हो गए क्या? अब reference दे देते. And now of course you can see the paper has been published recently, within 2-3 days or 4 days only. So if you put the word TLC hydrotropic solution on Google search, you will get that published paper. So details of so many drugs you will find from there. Here I have given the examples of only 2. But in that research paper which has been published, you will see several drugs have been done and several hydrotropic solutions have been tried. Okay, just I am giving the brief, very brief I am giving to you, but see the detail, and a very good paper is there. And in so many colleges, the same type of work can be performed. Means for please listen to me carefully. For each and every solute, for each and every drug, you can perform the TLC using hydrotrophy or mixed hydrotrophy. For each and whether it is water soluble drug, whether it is water soluble drug, you can perform the TLC without the use of any organic solvent, just by the use of hydrotrophy or mixed hydrotrophy. Now you see the application of this hydrotrophy in HPLC analysis. Now you see the reference now the reference you are reading here, novel RP HPLC method development and validation of cefixime in bulk and its doses form by using hydrotropic solution as mobile phase. Remy Madam, who is the assistant professor in one of the college, pharmacy college of Kerala, she is doing PhD on hydrotropic solubilization for UV analysis and HPLC. So this Remy Madam has done this work. So this is her work. So model used was this. The details you can see here. She has implied 6% weight by volume aqueous solution of sodium acetate hydrotropic solution as mobile phase after adjusting the pH to 6.2 with acetic acid. Why? Because if you make only the sodium acetate solution 6%, its pH is about 8 or 8.5, something like this. So what she has done, she has used acetic acid to bring down the pH from 8.5 to 6.2 with the help of acetic acid, and this solution was used as mobile phase for reverse phase HPLC of cefixime drug. Okay, the details are there. Okay, one more thing, Chennai, these are some of the details. Now another, same Remy Madam, this is another paper. Here so many validation parameters were there. Very big paper is there. A novel eco-friendly cost-effective mobile phase for HPLC, simultaneous estimation and validation of paracetamol and dichlorofilic sodium. 2 drugs are there in one tablet, paracetamol and dichlorofilic sodium. So they were assayed with the help of reverse phase HPLC in bulk and pharmaceutical formulation, okay, using hydrotropic solution as mobile phase. Here, she has implied 5% urea solution. It is not given in the slide, but she has implied 5% urea solution, aqueous solution of urea 5% as mobile phase to carry out this reverse phase HPLC of tablet containing paracetamol and dichlorofilic sodium. This is the complete reference of that paper. It is available online on Google search. If you see it, you will find all the details. Very big paper is there. Okay, one more paper. She has, I think, it might have been published or very soon it will be published. That is on ornithazole tablet. She has done a reverse phase HPLC of ornithazole tablet using, I think, sodium benzoate solution 4% she has used. I think anyway, but when that paper will be published, you can find all the details in that ornithazole tablet estimation by reverse phase HPLC using hydrotropic solution. So what we are observing here, there is no use of methanol, no use of acetonitrile, which are mostly used in HPLC. Just by use of aqueous solution of hydrotropic agent, you are performing the HPLC. One thing you please listen carefully from me. What I am saying is, for each and every water soluble drugs, you can perform the reverse phase HPLC using hydrotropic solution. For all water soluble drugs or all water soluble compounds, you can perform the reverse phase HPLC using hydrotropic or mixed hydrotropic. Okay, I am not saying for all poorly water soluble drugs. Here there is some limitation. In case of poorly water soluble solutes or drugs, there is limitation. So anyway, I am leaving this thing up to here only. But what I am telling you, all water soluble solutes or drugs can be for the reverse phase HPLC can be performed for all water soluble solute or drugs. Okay, now coming to mixed hydrotropy. You see, I told you that hydrotropic solubilization is about 100 years old concept. In year 1916, I think this word hydrotropy was originated in 1916, I think. Okay, now you see, no one has used mixed hydrotropic solubilization before 2008. I have started mixed hydrotropic solubilization, and this is also quite a good concept of mixed hydrotropic solubilization. By mixing several, means more than one hydrotropic agent, making a concentrated solution can also be employed for solubility enhancement of poorly water soluble drug. Sometimes you get additive solvent character, sometimes you get synergistic solvent action. So here, a few examples I am giving you. And of course, this is a M4 project done by Hitesh Jagwani in year 2008. Okay, what he has done, the solubility of furosemide was checked in water. The solubility of furosemide was 0.008%. In 40% urea solution, the solubility was 0.191%. 40% sodium acetate solution, this was the solubility. So 40% sodium benzoate, 40% sodium citrate, these were the solubilities. Now he has made again by the same trial and error at random. There was no systematic method, but by trial and error, he has used so many combinations of all these four hydrotropic agents: urea, sodium acetate, sodium benzoate, and sodium citrate. Number 6, you see 15% sodium benzoate, 5% sodium acetate, 5% sodium citrate, and 15% urea solution. So total became 15 plus 5 plus 5 plus 15. So total became 40% mixed hydrotropic solution. The solubility was 4.247%. Now you see, earlier in the single hydrotropy, urea 40%, 0.191, 40% sodium acetate, 0.239, 40% sodium benzoate, 2.157, 40% sodium citrate, 0.129. Okay, but here you see just by mixing in different ratios, we see a synergistic solubility enhancement, 4.247%. Okay, similarly in number 7, 20% sodium benzoate, 5% sodium acetate, 5% sodium citrate, 10% urea. Now you see the solubility 4.524% synergistic solubility is there. 8 number, 10% sodium benzoate, 5% sodium acetate, 5% sodium citrate, 20% urea. Total became 40. This total 40% solution was kept constant. So here the solubility was 3.085%. Again, the synergistic solvent action is there. So sometimes we get additive effect, sometimes we get synergistic solvent action. Actually, I have not given here the reference, but this paper is also published. If you put these words, Hitesh Jagwani, mixed hydrotropy, and furosemide. If you put these words on Google search, you will get a full paper. I'm sorry, I could not give here the reference of this. I think this was last slide. Okay, this was something about the mixed hydrotropy. Now, of course, Whatever I want to tell you is not complete here, but now I would like to stop my this lecture here. Now I would like to give the answer for the questions which have come in the minds of the audience. इसमें इसको मिनिमाइज करना पड़ा तो एस्केप मारूं क्या और ठीक है वो लोग कैसे दिखेंगे उन लोगों को लोग लाओ ना फोटो उन लोगों का फोटो कैसे आएगा हाँ 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 स्टॉप से ठीक है नाउ लेक्चर इज ओवर विशाल जी हैं? अच्छा थोड़ा पीछे
Hello. Thank you, sir.
हाँ हाँ ओके थैंक यू
Hello. Yes, sir. Yes. If any delegates any query regarding the this mixed solvency concept and their applications, then in a economical applications in a mixed solvency concept, so put your question or a query in a chat box. Okay, thank you, sir. I am sharing my vote of thanks. So, on the behalf of my college, and first of all, to spread my most sincere thanks to the today's chief and eminent speaker or the guest of Dr. Rajesh Kumar Maheshwari, sir, from the Indore, who gave his vital time from his busy schedule and to grace this webinar and. We all the Parikrama staff or the Parikrama faculties or the group of institution of Parikrama to grateful to the Dr. Rajesh Kumar Maheshwari sir for very energetically and enthusiastic demonstrating his very huge research on the topic of economical applications in a mixed solvency concept in 2009. So thank you, sir. I would like to place my heartily thanks you, thank you, sir. And I would like to thank you, our principal, sir, Dr. Sulil Lirmal, sir, for his enthusiastic, enthusiastic supports and alwaysly motivations. And also to place my heartily thanks to all the volunteers and the faculty members of Parikrama and research scholars so who made this webinar and I would like to thanks for giving your valuable times and patience. So thank you once again, sir.
Okay, thank you. I would like to add a few words, sir. Few words I would like to tell you that if some of the students they take such type of work, hydrotropy, mixed hydrotropy or mixed solvency concept, they should do this work and they can take help of mine. Okay, of course you can explain them, but they can directly contact me. Anyone who is interested on such a type of concept, I would like to explain each and everything. I can help through WhatsApp or I can help by telephone or by email and all that. So I would like that some of the students should do such type of work in your college also, Parikrama College of Pharmacy. Okay.
Yes, sir. Thank you, sir, for giving this golden opportunity to our students and faculty members, also giving to this opportunity towards our MPharm research scholars, sir. Thank you once again, sir. And thank you, principal,
thank
sir,
you.
to arrange this platform for to giving this webinar on this very golden topic on mixed solvency concept, sir. Thank you, sir, once again.
Okay, thank you. Jai Shri Krishna.
Thanks.
Jai Shri Krishna. Thank you, sir.
Jai Shri.